Aloha kako! Welcome back to the Nea Papakahana Online Professional Development for our 7th grade curriculum, Let's Take Care of the Lo'i. In this video, we'll be covering Unit 4, Geometry. Here are the Common Core standards that will be covered in this unit. Please feel free to pause this video if you would like to read them more thoroughly. If you have a copy of our curriculum, you'll be able to find all of these standards at the very beginning of the unit. The standards in this unit come from the Common Core domain of geometry, as denoted by the letter G. The standards in this unit have a major emphasis on how shapes appear and how the measurements can be used to solve problems. In particular, we have to draw and describe shapes based on given sides and angles. We also have to draw and describe lower dimensional shapes that we get from slicing three-dimensional ones. In this unit, we'll also be solving problems using scale drawings, areas and circumferences of circles, areas of polygons, and surface areas and volumes of right prisms. The Unit 4 activity that we'll be reviewing in this video is the Module 9 Circumference, Area, and Volume Activity 1. There is also an Activity 2 that directly follows the story from this one, but although we highly recommend you do both activities, we'll only cover the first one in this video. In this activity, we'll be learning about a traditional fish trap called an umu. An umu is basically a tiny home for fish that we can build by stacking rocks or coral. We'll allow the fish to chill out in our umu and we'll feed the fish until they get big. After they've had a long happy life, safe from predators, we'll cover the umu with a net and collect the fish. In part 1 of this activity, we'll need to calculate the volume that is taken up by this umu. This umu is the shape of a trapezoidal prism. Please pause the video and find its volume. Aloha, welcome back. To get the volume of this umu, we need to find the area of the front trapezoidal face. Then we need to multiply that front face by its distance to the trapezoidal face in the back. The area of the trapezoidal face is the average length of the top and bottom parallel sides multiplied by the distance between those two sides. The average length of the parallel sides is 1/2 times the sum of 2 and 4 feet. This comes out to 3 feet. The distance between the parallel sides is 1.5 feet, so we have 3 times 1.5 feet. This tells us that the area of the front trapezoidal face is 4.5 square feet. We get the volume by multiplying the area of this front face with its distance to the back face. So we get 4.5 square feet times 4 feet, which comes out to 18 cubic feet. In part 2 of the activity, we'll try to approximate how much fish is in this umu. Suppose that 0.3 pounds of fish are in each cubic feet of the umu. What is the total weight of the fish in the umu? Please pause the video and use your answer from part 1 to answer this part. Welcome back. The volume of the umu was found to be 18 cubic feet, and we have that there is 0.3 pounds of fish per cubic feet of umu. So when we multiply these numbers, we'll see that there is 5.4 pounds of fish in this umu. In parts 3 and 4 of the activity, we talk about how to catch the fish in the umu. There are several ways to do this. We can hold a net on one side of the umu and scare fish into it, or we can make a fence with a net and surround the umu, or we can just cover the entire umu with a net and take the rocks out one by one. In part 3, we'll talk about the size of the net needed to cover the umu. We basically need a net with an area that is large enough to cover the exposed surfaces of the umu. This includes the top of the umu, the 4 sides, but not the bottom. We're not going to actually calculate it in this video. Instead, let's pause the video, take a good look at the umu, and come up with a plan for how you would calculate the surface area of the umu, excluding the bottom. Okie dokie, welcome back. So to calculate the exposed surfaces of the umu, we need to calculate the areas of the top rectangle, the 2 slanted rectangles on the sides, and the 2 trapezoids in the front and in the back of the umu. We conclude this activity by looking at part 4, Here we see 6 different circular nets. We can calculate the areas of each net and find out which nets are large enough to cover the ubu and which nets are not. Please feel free to complete parts 3 and 4 on your own if you want, or check the teacher's guide if you're stuck. But we're going to wrap up the video here. We always recommend modifying our activities to better fit the needs of your classroom or your teaching style. For example, we think that a good way to ease your students into this activity is by starting with an umu that is shaped as a rectangular prism instead of a trapezoidal prism. You can also create more difficult prisms and complicated shapes created by combining several prisms. You can even modify Part 4 to prepare your students for working with squares and square roots, which will be of a major focus in 8th grade. One way to do this is by having your students find the minimum radius needed to cover the prism with a circular net, and you can have them find this radius to the nearest tenth of a foot. Because it's unlikely that 7th grade students are comfortable with square roots, they probably have to resort to creative methods to solve this. One effective method that students might discover is by guessing and checking. By plugging in different radii to the formula for the area of the circle, the students will get to practice skills they'll need to work with functions in higher grade levels. You can also turn this activity into a mini project by having the students design and build scale models of umu. This allows the students to work on their 3-dimensional spatial reasoning, their skills with rates and proportions, and prepare themselves to investigate dilations that will be of importance in 8th grade. Okie dokie, that's all we have for this video. We look forward to having you join us in our next video for Unit 5. Ahui ho!